Looking at this sixth video, we're looking at basically how lines and circles intersect or don't. So this skill will involve being able to substitute into a quadratic, leading to a quadratic equation. Knowing your discriminant, remember that's the bit inside the quadratic formula, the bit inside the square root, which is b squared minus 4ac. And being able to factorize where it's appropriate. Now, we have three basic situations that can occur with a circle and a straight line. This line can intersect the circle at 2 points, that's called a chord. This will happen when we've created our quadratic equation after substituting. We will find in this case that the discriminant is greater than 0 and we get two solutions which will give us the two separate points. We can have that when we've done this that our discriminant's equal to 0, which means we have one solution, well, one repeated solution, be a repeated bracket when we're doing it, and 1 point. Okay, and we could have that it misses the line entirely, so the circle and line do not intersect, in which case the discriminant will be less than 0 and there are no roots or points. So those are our three basic situations. If we're asked to prove tangency, we can either just use a discriminant and show it's equal to 0, or we could show that there's a repeated root. Okay, so when you factorize, you might have x minus 2, or x minus 2 in a bracket squared. Saying that there's a repeated root is equally as good as saying that the discriminant's equal to 0 in order to show that it is a tangent. Obviously, if we want to know what the point is, we're going to have to factorize it and put it equal to 0. Okay? So, we'll go through an example of each sort of these. Our first example there says, show that the line y equals 2x plus 8 is a tangent to the circle x squared plus y squared plus 4x plus 2y equals 0 and find the point of contact. Now, it's set up nicely for substituting for y. So my first bit is I'm going to substitute for y in the circle. So instead, we've got x squared, that's fine. So instead of y squared, it's going to be 2x plus 8 squared plus 4x plus 2y. Remember, we're using that for y. There's no number term, so that's equal to 0. Okay, so that's the substitution. That's the first thing we do, substituting for y here. Now I'm going to multiply out and tidy up. Remember, I'll do it with the first one. Remember, if we're doing that, it's 2x plus 8, 2x plus 8. Don't forget to do the middle bits. Yeah, that stands for that. I wouldn't necessarily write this step in, but it stops you making the mistake of just writing down 4x squared plus 64 and thinking that's it. It's not. You've also got the 16x and the 16x, which is 32x. So that gives you your 4x squared plus 32x plus 64 plus 4x plus 4x plus 16 equals 0. Okay, when we tidy up, we'll see that that gives us 5x squared plus 40x plus 80 equals 0. I can divide everything by 5 here, give me x squared plus 8x plus 16. Now, to show it's a tangent, I could use the discriminant, yeah, b squared minus 4ac, and show that that's equal to 0. That would tell me it's a tangent. But as I want the point, I'm just going to continue and mention it's got a repeated root. Okay, so I can see that if I factorize that, it's x plus 4 equals 0, which you'd write as x plus 4 squared equals 0. We'd normally write it like that. So at this stage, I can say that's a repeated root. Therefore, a tangent. Remember, I need to state that, or I need to show that the discriminant's equal to 0. If I was doing the discriminant, I could show that, look, b squared, so 8 squared, take away 4 times 1 times 16, and that gives you 0. Therefore, you could say it's a tangent. So you do that or that. You wouldn't do both. And to be honest, with this one, since we need the point anyway, I'd use the repeated root method here. Okay, so that will give us x equals minus 4, doesn't it? Which is our repeated root. Going back, we would, of course, don't use the circle substitution because that just makes it more difficult. Use the straight line. So you've got y equals 2 times minus 4 plus 8. Okay, which gives you 0. So the point of contact is minus 4, 0. Okay, so remember, as well as solving it and saying what your point of contact is, either state it's a repeated root, therefore it's a tangent, or show that discriminant 0, therefore it's a tangent. Okay, second example, show that y equals x minus 1 is a chord to the circle and find its intersection points. So again, the first step is we're going to substitute. Again, it's nice and straightforward in that we've got y equals x minus 1, so it's not that hard a substitution. So we've got x squared plus x minus 1 squared plus 8x minus 4x minus 1, because remember we're replacing y with x minus 1, minus 29 equals 0. Again, we'll multiply out, so we've got x squared plus x squared minus 2x plus 1 plus 8x minus 4x plus 4 minus 29 equals 0. Tidying up, we've got 2x squared minus 2 minus 4, so plus 2x. That's 5. Take away 29 is minus 24. Equals 0. Divide everything by 2. You've got x squared plus x minus 12 equals 0. Difference of 1, so it's going to be, and one's got to be positive, one's negative, so it's going to be plus 4 and minus 3, isn't it? Which gives me x equals minus 4 or 3. And you can say 2 roots, therefore y equals x minus 1 is a chord. You can do it that way, or remember we could have used the discriminant as an alternative way. You could have done discriminant equals b squared, which is, 1 squared minus 4 times a, which is 1, times c, which is minus 12. That gives me 49. Discriminant greater than 0, therefore chord. That's the other way of doing it, to show that it's a chord, given that we're asked to show it. Remember, because we want the points, it's just as easy to do it that way. But we also need the y coordinates, and I'd be using the x minus 1 here. So minus 4 minus 1 is minus 5. 3 minus 1 is 2. So our 2 points of intersection are minus 4 minus 5 and 3, 2. And that's that one. That's where that line intersects that circle. As I said, you don't need to do both, but you either state once you see there's two roots, there are two roots, therefore it's a chord, or you show that the discriminant is equal to is greater than 0, therefore it is a chord. Looking at our third example, this time it asks me to show that this line does not contact the circle. This means I'm going to have to show that the discriminant is less than 0 here. Okay, so same as before, we have to adjust this. We have to substitute. So as we're substituting, we've got to rearrange this for y. So you've got y equals minus x minus 2. Okay, that's what you're substituting for y. Into this circle here, so that's going to be x squared plus minus x minus 2 squared minus 6x minus 8 minus x minus 2 equals 0. Okay, so let's multiply out. If you multiply this one out, it should give you x squared plus 4x plus 4 minus 6x plus 8x plus 16. That's what you get if you multiply these out. Okay, just be careful. If they're both negative and you're squaring it, you know everything's got to be positive at the end. Okay, but now let's simplify this a bit. You've got 2x squared, 4x plus 8x is 12x, take away 6x is 6x. 4 plus 16 is 20. Can divide it by 2 to make the numbers a little smaller. Remember what I said, we've got to look at the discriminant here. So you've got that the discriminant is b squared, so that's 3 squared, minus 4 times a is 1, c is 10. So that's 9, take away 40 is minus 31. So you can say the discriminant is less than 0, therefore no real roots, and line does not intersect the circle. Okay, so you have to show the discriminant's less than 0 here, and then you can simply state this line does not cross this circle.